This is Akashvani. In the program Spotlight, now we bring you a discussion on ISRO's Test Crew Escape System, first human spaceflight mission Gaganyaan. The participants are Dr. T.V. Venkateshwaran, Senior Scientist from Vigyan Prasar, and Sagar Kulkarni, Journalist.
ISRO conducted the first test flight of the Gaganyaan project this morning. The importance of this development flight. Dr. Venkateshwaran, please tell us about the significance of the first development flight of the Gaganyaan project.
ISRO was basically what it was doing, whether it is PSLV or GSLV, they were taking satellites to space or maybe spacecraft to some of the celestial objects. But they are all goods, right? But now with the Gaganyaan project, you are looking forward to taking human beings to space. So which means lorry operator has to now operate a bus. See, that's the difference. Not only that, you are converting your lorry into a bus. So when you are redesigning your lorry into a bus, there are a number of features that you will have to incorporate so that the human being can travel safely. What is happening in the human-rated launch vehicle, that is a remodification of LVM. That LVM is being remodified. That's what is happening. So what today happened was one feature that they want to add to the human-rated launch vehicle. That component they have tested today.
So this was a crew module test and how a crew module can be extricated safely in case of some difficulty. So tell us what this crew module is about.
Crew module is kind of a, let's say, a place where the crew will sit and function when they go to space. Actually, there'll be two parts to the module, basically the spacecraft. There'll be something called as a service module and a crew module. The service module will have fuel, small rockets, accessories like batteries and so on. And then the crew module is a place where you actually, it's something like, for example, if you are looking at a car, there is a place where you sit and drive the car, right? But then in the front of the car, you have engine. In the back of the car, you have, let's say, dicky or things of that kind, right? So the space where human beings will actually sit, work, is called as a crew module. It's a small capsule. So what today happened is that suppose if you have to abort the launch somewhere in midway, maybe something malfunctioned and so your launch vehicle is going in a wrong direction. So what do you do? That's the question. So if it is only a satellite, there is a button called abort, you just press it, rocket will blast into pieces. But then when you have human beings inside, you can't do it. So you need to do something else, right? You have to take the human being to safety. So what you do is you attach a small rocket to the crew module. So when there is an emergency, when the abort mission is taken, what happens first is that the crew module separates from the launch vehicle and then this small rocket, the escape rocket starts working. It will fly in a different direction and take the crew module safe distance and a safe height. The launch vehicle which is malfunctioning will go in a different direction. Launch vehicle will disintegrate because of the abort explosion, but then the crew will be safe and the crew will be landed safely. When you want to build such a escape mechanism, something like, for example, when you build a bus, for example, a Volvo bus, in all these buses, you will find there is an emergency exit at the back, right? In the same way, you need to put some emergency exit facilities when you are having a human-rated launch vehicle. That's what ISRO tested today. In fact, actually, if you look at it, there are 4 stages in this emergency exit. The emergency can happen on the ground, in the launch pad itself. So that's called as pad abort. Okay, that test was done in 2018. So already we have finished one. The second is that when launch vehicle is up in the air, maybe not gone to a very great height, something like about 10 kilometers or something like that. And then the speed is something equivalent to the speed of sound. Around that stage, if you want to have an escape, you need one system. If the rocket has gone to a much greater height, something like 30 kilometers, 40 kilometers, 60 kilometers and traveling at multiple levels of speed of sound, then you need a separate escape system. And then finally, if you are kind of near space, when you have reached space, then you need a different escape system. So you need 4 different escape systems. We have tested one 2018. We have done the second now. D2, today it's called as TVD1, right? The next one is called TVD2. TVD2 will experiment the third escape system. And the fourth one will be done with Gaganyaan G1, which is basically a dummy module which will be sent to space. That itself will be the escape system that will be tested that time.
The rocket took the crew module to a height of about 16-17 kilometers and then the test happened. And then it splashed into the sea a few kilometers away from the launch pad. Multiple agencies must be involved in carrying out this test. How do we retrieve the crew module that's fallen in the sea.
Exactly. You got the right point. Why we do this kind of test is that because there are multiple agencies, multiple systems have to work in complete synergy. See, the launch vehicle reached a height of something like about 9 kilometers and 10 kilometers where a false emergency was detected and the abort command was given. False emergency because it was not actual emergency. So we want to create a situation where an emergency occurs, then what happens? That's what we want to test, right? So somewhere around 9-10 kilometers this happened. So immediately in a flash, not even one cannot say that flash of a second, maybe just a bat of your eyelid, the crew module and launch vehicle separated. At around 10 kilometers, they separated. And then there is a very high-speed rocket in the crew escape system, which can immediately ignite. It can burn very, very fast. So which means that it can move very fast. And then it took the craft to a height of 16 kilometers. So which means you are putting something like about 5-kilometer distance between the launch vehicle and the crew module. Because launch vehicle is going to explode. Remember that. I mean, in real situation, not today, it will explode. So you need to keep a distance. So, and this happened within 10-15 seconds. When 10-15 seconds, I mean, it went to a height of 16-17 kilometers. So it was at safe distance. And then it started falling towards the earth. And then one by one, different kinds of parachutes. There are 3 parachute systems. They all unfolded one by one and then safely landed in the ocean. And once it safely landed on the ocean, somewhere around 8 to 10 kilometers away from Sriharikota, the drones were watching this. They were able to capture it. They were able to follow it. And then because you know the location through drone, Coast Guard, naval ships will go and retrieve it and then bring it back to the shore. That's the whole thing. So multiple agencies, multiple systems, multiple things have to happen simultaneous. They can't happen at different times. They have to happen at flash of a second and they have to happen simultaneously.
Dr. Venkateshwaran, there were some anxious moments this morning when the engine failed to ignite just 5 seconds before the launch. So can it also be seen as a demonstration of ISRO's capability to call off a launch even at the last moment?
Exactly. It was not an engine failure to ignite. The engine ignited. At that moment, the onboard computers detected anomalies. Okay. That is, the parameter that it was detecting was not what it was supposed to be. So, feeling that perhaps that will lead to a disaster, the onboard computers took a decision to halt the automatic launch sequence and then the engine was shut off. I mean, before the engine could produce enough thrust. That's what has happened. What we come to know from Dr. Somnath's interview after the launch is that it was an error in the monitoring system. There was some malfunctioning of some instrument, which was set right and then everything was okay. I mean, it happens to you and me also, right? One day we put our petrol tank full and then next day morning we switch on our car and then fuel tank shows empty. And then you and I are surprised. And then you find that it's actually not empty, but there is some malfunctioning in your indicator. Maybe some loose contact or something, and once you set, everything is fine. Something similar has happened in this particular case. And as you rightly pointed out, the onboard system was able to detect this anomaly and then shut off. Itself is a very important step because that is how you save failures. You save yourself from failures.
We are talking about sending Indian astronauts to space. Have these astronauts been selected already?
Yeah, around 19 people were identified in the initial round. They were given initial training and then after screening, the numbers got reduced step by step. And then finally now around 4 people are in intensive training. And ISRO has also established some training facilities in Bangalore. Because of the COVID, the training could not go the way that we had actually planned. I mean, many systems did not work and so on. So now ISRO is also setting up its own training center in Bangalore, for example, flight simulator and things of that kind. The further training will also take place now. And within this 4, few of them will be selected finally for going in the major mission.
So what is the actual mission, the human space flight, and when do we see actually humans traveling to space?
So currently with the kind of timeline that ISRO is thinking that we are looking at the launch of Gaganyaan with the human Gaganyaan mission somewhere in 2025. The first mission is essentially to demonstrate. Technology demonstration.
Right.
There may not be any great scientific or other work that will be coming out of it, but that will demonstrate that all your systems are working, that your crew module is functioning fine. You are able to send a human being to space and then bring them back safely. That's really the main goal of the Gaganyaan 1. Later, you will think of experiments which can be carried out in space and only in space, because in space you are in what is called as a microgravity. That is basically you are in a situation of weightlessness. So there are a number of very interesting experiments that you can carry out there. Very simply put, for example, if on the Earth, if I'm making alloy with the two different metals and one metal is slightly denser than the other, okay, the denser metal will go to the bottom, even if you are going to do a very good mixing and all that. You won't get really a very even mixture of these two metal alloys. But in space, because it's weightless, you can get a very perfect, much better alloy mixing and so on. So a lot of such kind of experiments one can do in space, learn about things and then how materials behave and so on. Those kinds of work will take place in future.
So in the first space flight, how much time will the astronauts actually spend in space, and at what altitude do you expect Gaganyaan spacecraft to orbit the Earth?
Gaganyaan will orbit somewhere around 300 to 400 kilometers above Earth. That will be the normal human space flight trajectory. How long will depend on various parameters, and that has not been finalized. It may be just one orbital flight or it may be multiple orbital flights. That will be zeroed in only when many other parameters are very clear. At this point of time, it's not a final decision.
Dr. Venkateshwaran, the Prime Minister recently had a meeting with senior scientists of ISRO, and he has set some goals for them to set up an Indian space station by 2035 and also try to land a human Indian astronaut on the moon. How feasible are these targets?
It is a very eminently possible scenario. There is nothing that prevents that from us achieving those goals. I mean, there is no, it's only that we need to develop technology and we need to develop resources, and then we need to develop those kinds of capacities, both human and otherwise. That's the only thing. Setting up that kind of a goals usually helps in the sense that then you have a focus, you are able to develop technologies which will synergize to that particular goal. In that process, you will be learning a lot of very advanced technologies. You'll be exploring a lot of such technologies which otherwise we will have no opportunity to do so. So setting up that goals will actually make ISRO refurbish itself for 21st century. That's a very important part of this goal setting and then working towards it.
Prime Minister also stressed on carrying out interplanetary explorations, and ISRO also has plans to launch missions to Venus and also carry out a Mars landing in the possible future. So tell us about that.
We have done a good work with regard to our Chandrayaan. There have been 3 missions, of which one was a partial failure. We have had a very successful Mars mission, Mars orbiter mission. That's very successful. I mean, in fact, internationally it's being acclaimed very well. And all this we achieved with launch vehicles which are not as powerful as what is there in the international market. So if you look at a Chinese or American or a Russian launch vehicle, they can take something like 20 to 25 tons to low Earth orbit. We can just take about 8 tons. Our best of what that is GSLV can take only about 8 tons. But with this GSLV, we have been able to achieve this much. What's called as a modular approach, what ISRO has worked out for the interplanetary travel, instead of developing a very powerful rocket which will otherwise be white elephant. So instead of going for a white elephant route, ISRO chose a very different technologically sound route for space exploration. And the space exploration is necessary from 2 counts. One, with that the Indian Research Institute will be able to do really good work. I mean, international standard work, like for example the Aditya. We'll be able to do a good solar physics in addition to space weather prediction. And studying planets like Venus or Mars is actually not just studying about those planets, but is also actually reflecting upon, there was water, surface water on Mars. Now there is none. What happened to it? By understanding it, we can understand the climate change in Earth. Similarly, the Venus is into a very deep runaway greenhouse effect. Okay, I mean, it's sizzling hot. So again, by understanding Venus, we'll be able to model our climate better. We'll be able to take scientifically driven policies for preserving Earth, mitigating climate change and chasing challenges rising out of it. This, when interplanetary travel, is not just, demonstration, but also is very deeply useful for both human resource development and also making our own policies in the current context of climate change.
So indeed, there are exciting times for the space exploration ahead. Thank you for talking to us, Dr. Venkateshwaran.
Thank you so much. It was a very wonderful conversation.
You were listening to a discussion on ISRO's Test Crew Escape System, first human space flight mission Gaganyaan. The participants were Dr. T.V. Venkateshwaran, Senior Scientist from Vigyan Prasar, and Sagar Kulkarni, Journalist. This program was produced and presented by the News Services Division of Akashvani. You can listen to it on a mobile app News on AIR. This program is also available on our YouTube channel News on AIR Official. You may share your feedback about this program through email at airnsdtalks@gmail.com or WhatsApp on 9289094044.